One moment it's a helicopter, rotors chopping the air, hovering over a rooftop. The next, those rotors tuck away, rear fans kick in, and it rockets forward like a jet. Meet the Sky Serpent, a transforming rotorcraft designed to kill two birds with one wing, vertical takeoff and supersonic dash. It's the kind of machine that rewrites mission briefs, land anywhere, then disappear into the sky. Military planners and extreme mobility designers have always dreamt of a single airframe that can hover like a copter and sprint like a plane. VTOL and tiltrotor designs got us close, think Osprey. But the Sky Serpent aims to take that leap further. Seamless transition, reduced vulnerability during mode change, and enough speed to outrun threats that would chew a helicopter alive. This is a story of folding aerodynamics, clever propulsion, and the stubborn demands of physics. It's also one of strategy, a vehicle that changes how you insert troops, chase targets, or vanish after a strike. The concept: two modes, one body. At heart, the Sky Serpent is a hybrid. Hover mode, wide, slow rotor disc for vertical lift, precise loiter, and low-speed maneuvering. Sprint mode, rotors retract or shut down, aerodynamic surfaces reorient, and high-speed forward propulsion takes over. Transitioning between those modes is the whole trick. Designers focus on stability during changeover, thermal management as engines shift regimes, and redundant flight controls so a single component failure doesn't become a fatal one. The prize is huge. A single craft that lands where helicopters do, then escapes at plane speeds that leave anti-aircraft systems confused. Propulsion and aerodynamics. High-level engineers mix approaches. Some concepts use tilting fans that swivel from vertical to horizontal thrust. Others favor ducted fans that stow inside the fuselage for high-speed airflow when hidden. Another path is dual propulsion. Quiet lift motors for hover, and a separate high-thrust jet for dash. Aerodynamically, the fuselage must be smooth enough for jet flight, yet wide enough to house rotors and landing gear. Wing-like surfaces pop out during sprint mode to provide lift, while control surfaces shift to manage yaw and pitch without rotor wash. The design challenge is balancing weight, drag, and heat, all without turning the craft into a lumbering compromise. Operational use. Why militaries care? The Sky Serpent's operational case is obvious. Insert troops where runways don't exist, then flee faster than conventional helos. That's mission flexibility in short supply. Special operations could land a small team in dense urban zones and extract them before anti-air respond. Recon assets could hover for surveillance, then sprint to safer airspace at supersonic or near-supersonic speeds. For naval forces, a Sky Serpent could operate from small decks, hover to pick up a boarding team, and then dash to a carrier for extraction, all without needing a long runway. For Coast Guards, it means reaching a flooded zone vertically and then moving survivors rapidly along coastlines. Tech roadblocks. What makes it hard? Physics is ruthless. Rotor downwash plays havoc with nearby structures. Folded rotors must clear the fuselage cleanly. Heat from sprint engines can damage the aircraft's own surfaces. Control systems must compensate for enormous shifts in lift and thrust in a matter of seconds. Redundancy, sensors, and real-time flight control algorithms are non-negotiable. Another issue is maintenance complexity. A transforming airframe multiplies moving parts, hinges, seals, retractors, each a point of failure. Reliability must be much higher than for single-mode craft if lives will be aboard. Noise and signatures also matter. Hovering rotors are loud and expose the craft to acoustic and radar detection. Sprinting like a jet creates a different thermal and acoustic profile. Designers must consider stealth coatings, folding geometry that reduces radar returns, and operational tactics to avoid detection during vulnerability windows. Prototypes and pathways. What's real today? No mass-produced Sky Serpent exists yet, but several advanced programs point the way. Tilt rotors that blend vertical and forward flight, experimental ducted fan prototypes, and modular unmanned systems that test retractable rotors. Aerospace labs are perfecting the control software and materials required for folding components that survive flight loads. Unmanned demonstrators are the likely first step. Drones that validate transition sequences, structural hinges, and flight envelopes without risking crews. Scale successful, then human-rated prototypes follow. Militaries typically fund high-risk projects like this for years before any fielded version appears. Strategic and ethical considerations. A Sky Serpent in play changes rules. Rapid insertion strike platforms would compress decision windows and complicate air defense. They create asymmetric advantages for forces that can afford them, widening capability gaps between nations. The tech could empower covert raids with less warning time for defenders. Ethically, faster insertion and extraction capabilities raise questions about escalation, deniability, and civilian risk in urban environments. Faster craft may reduce loiter time for positive identification, pressuring commanders to make split-second decisions with less context. The Sky Serpent promises freedom from runways and the speed to vanish into the horizon. But every time we fold rotors and point noses forward, we bend the rules of engagement and logistics. We get a craft that can be everywhere and nowhere, a shape of mobility that's equal parts promise and problem. When machines learn to change shape mid-flight, the sky stops being a single domain. It becomes a theater with new rules, new dangers, and new winners.